Okay, here is the experiment 112 chemical equilibrium and the Chatelier principle. And I'm going to follow the procedure and you're going to answer a question based on the observation. So, part 1, chromate ion can be converted to dichromate ion by its reaction with acid. This is the reversible reaction as indicated by the double-sided arrow down there. Okay, so the equilibrium already put down there. So step 1, I'll place 3 milliliter of potassium chromate solution in a test tube. 3 milliliter. Okay. What color is the solution? Observe and write down the color next to the equation above. Okay. Step 2, I'm going to add several drops of the 3 molar sulfuric acid to the test tube. You're going to observe what happened to the color of the solution. So I'm going to add drops, just a little bit. You can see the color change. Okay. All right. So write a color on the line next to the equation above. Okay. Now step 3, then you're going to answer the question there. Which species actually means which ion in the equilibrium reaction causes the forward shift when you add the sulfuric acid. So think about the sulfuric acid, but write down the ions, the ion which make the change. Okay. Step 4, add several drops of the 6 molar sodium hydroxide to the reaction from step 2. Okay, I'm going to add several drops of the sodium hydroxide. You see the color change? Okay. All right. And you need to answer the question on question 5. What does the color change above indicate the direction of the equilibrium shift? Okay. And also, question 6, you need to answer what caused the shift. Think about sodium hydroxide, which is the base, and in the reaction, you may have an acid there, so think about acid and base, what's going to happen. Okay. That's part 1. So part 2, acetic acid equilibrium. Okay. So here, question 1, you can just read and be able to answer the question 1. Question 2, I'm going to put 3 milliliter of the 0.1 molar acetic acid into a test tube. Okay. I'm going to just pour it. Okay, about 3 milliliter. All right, and I'm going to add 1 drop of the methyl orange indicator. Okay, now you're going to observe the color of the test tube. 1 drop. Okay, what color is the solution in the test tube? You can answer that question. Okay, now move to step 3. I'm going to add several drops of the 0.1 molar sodium acetate to the test tube. Okay. Sodium acetate. All right. Several drops. So you are going to observe the color change and decide which direction did the equilibrium shift. So it's gradually changing color. Okay, so you already see the color change. Maybe a little more, just make the color change more obvious. Okay. All right, so question 4, what ion caused the shift in the equilibrium? So make sure you figure out the ion, not the whole molecule. Okay. Now move to part 3. Saturated sodium chloride solution. We are going to look at the saturated solution in an equilibrium and how we can shift the equilibrium. Okay, so I'm going to put 5 milliliter of saturated sodium chloride. So this time you have to observe very closely, okay? So about 5 milliliter. I'm going to add 2 milliliter of 12 molar HCl, okay? And you're going to take a close look and describe the change. Okay. So the change is quite dramatic. Okay, so you're going to describe it. Don't forget color or other observation. And look back of the equilibrium equation, decide which direction did the equilibrium shift based on the reaction, based on the observation, and decide what ion caused the shift. Now move to part 4. We have the 2 solutions we're going to mix. So step 1, I'm going to make the stock solution follow the guidance. Then I'm going to split the stock solution in 3 different test tubes. In the menu it says 4, but actually we only need 3. Okay. Then you're gonna observe the 3 test tubes change. Okay. So first, the stock solution, I need 100 milliliter of the distilled water. Then I'm going to add the iron chloride and potassium cyanide into distilled water. So it's both about like a 2 milliliter. So just 2 milliliters. So this is going to be our stock solution. You can see the solutions. This is pretty much the 2 reactants mixed in the equilibrium equation. Okay, so I'm going to split this into 3 test tubes, about 5 milliliter in each. Okay, so now step 2, to test tube number 1, I'm going to add 20 drops of the KSCN. Then you're gonna watch the color change, then decide the equilibrium shift direction. Okay, so I'm going to add 20 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. Okay, if you want to see the color change, you can compare to the original one. It's a little bit changed, but I think you can see that the difference. It's darker or lighter, whatever you decide. Okay. All right. Now, question 4, you're going to answer what ion caused the shift. So you need to look at back of the equation, think about what you added. Okay, now question 5, you're going to use the Chatelier principle to explain the observation. Okay, now move to step 6. To test tube number 2, we're going to add 20 drops of the 0.1 molar iron chloride. So you're going to observe the color change. So add kind of quick. Okay, now compared to the original one, what do you think? It's a darker or lighter? Okay. So this is number 2. Again, we're going to answer question 7 and 8 based on that. Okay. Okay, part 5, cobalt chloride. So you can see the equation still. On the left side you have pink color, on the right side you have blue color. So this time you're going to observe the pink and the blue color change to decide the shape and explain why. So I'm going to follow the guidance to prepare the solution. So it says 2 milliliter of cobalt chloride, okay, cobalt chloride into each of the 3 test tubes. So 3 test tubes. All right, 2 milliliter. It's going to be 2. Now you're going to see the color, okay? This is the source of the COH206 ion in the reaction above. All right, we are going to use this test tube as the control. So you can see this is the original color. So anything changed that you can based on that. Okay, so now go to step 1. To 1 tube, add about 3 milliliter of concentrated hydrochloric acid. 3 milliliter, drop wise. Then you're going to see the color change gradually. Let's compare with the original. Seems like still not much change, so keep adding. Here. Still not much change, right? Yeah, we needed to add more. Okay, it looks like it still be the original color. It's against the white. Still, right? Same color? Maybe, let's see if it's, no, same color. Okay, remember you add the concentrated hydrochloric acid into it. Okay. Now, to the second test tube, move to step 3. To the second test tube, add 1.5 grams of the sodium ammonium chloride and shake it to make a saturated solution. So number 2, we're adding I'm going to add kind of a piece size of it. Get in there. Okay, let's fix that. So if you see some of the solid stay on the bottom, that means it's saturated. It cannot dissolve more. Okay, then compare the color to the original. So there are some changes, right? It's more pink or more blue. Yeah, compared to this one. This one is more pink or more blue. What do you think? Okay, maybe slightly change the. You needed to observe carefully. Okay. All right. So now move to step 4. This time we are going to put a test tube with the ammonium chloride, number 2, and the control in boiling water. Okay, so you're going to see the color change. All right, so this side will be the one with the ammonium chloride. This one is the control. So I'm on the left hand control. So I'm going to put in the boiling water. You're going to see the color change. So you have to wait a little bit. So the change is already happening. Okay, now take a look at the change. You see that this one with ammonium chloride, this one is a control. When heated, it moved to what side? Which side? Okay, all right. Now, step 5, cool the test tube under cold water tape, okay, and indicate the color after the change still. Okay, I'm going to cool it down, use water. It's already cooled. Look at the color. Will that change back? Okay, all right. So you're gonna write down the observation. Okay, question 6 and 7 will be the answer based on the observation. And in this part, you need to think about the reaction because the heat is involved as a factor of the equilibrium. So your answer may be thinking of endothermic or exothermic. You needed to think about the heat in which side of the equilibrium to make sense of this observation. Okay.